Hello and welcome to Train Signal. You are watching a lesson about Linux run levels and system shutdown and reboot. For me, one of the most difficult aspects of learning a new operating system was the differences in terminology. I'd spent years learning the file names, commands, utilities, and other OS-related terms of Windows, and they were firmly ingrained in my mind. The challenge then was to assimilate new information, retain the old, and to make sure that I didn't mix up the two. Linux has its fair share of, shall I say, unique-sounding terminology. So when I first heard the term run level, my eyebrows knit together in concentration, wondering what on earth a run level was. I can guarantee you that the concept isn't nearly so intimidating as it sounds. In this lesson, we'll define run levels, and you'll see that there is a similar concept in Windows. We'll talk about the different run level services, the tools used to manage them, and how to easily check and change your current run level. As usual, along the way, we'll do some demonstrations to help reinforce the material. So fire up a terminal window, which of course should be second nature to you by now, right? Ready? Good, let's get started. So what exactly is a run level? Think of it as a mode of operation. And Linux has several modes that it can run in. For those of you familiar with the Windows operating system, a good analogy is the Windows Safe mode, which of course tells Windows to start the OS with a different set of drivers. This is particularly useful when you're troubleshooting a problem with your system. The same concept applies to Linux. It has 7 run levels, numbered 0 through 6, and the table below highlights the uses of each run level. The first is 0. As this switches the run level to another mode, it's referred to as transitional. Run level 0 powers down the system. 1, which you might also see as a lowercase or uppercase s, tells Linux to run in single user mode, which is typically used for system maintenance tasks. Under the Debian distribution, Run level 2 launches Linux in a multi-user mode with a graphical user interface called X. Let's move on to the remaining 4 run levels. We have 3 up next, and under Red Hat, Mandriva, and Fedora, which is fast becoming a personal favorite of mine, and in fact many other distributions, this launches Linux in a multi-user mode or networking mode with a command line interface. 4 is a run level that's unused and can be customized. Number 5 again for Red Hat, Mandriva, and Fedora runs just like level 3, but it adds a graphical user interface called XDM. This is an example of an often used default run level. Then we have run level 6, also transitional like 0, which shuts down and reboots the system. Now that we know the 7 Linux run levels and their purpose, let's take a quick peek and see what the current run level is on our test system. Switching back over to Fedora, let's click on Applications, System Tools, and Terminal. From here, we just need to type in the command run level and hit Enter. We see that our current run level is 5, which is multi-user mode with the graphical interface, and the N here means that the run level has not changed since we booted the system. In the boot process lesson, we touched on the etc init tab file as it related to the Linux boot process. If you recall, the init process is first run by the kernel and handles loading all other processes, and it is configured in the etc init tab file. Here you can add or remove entries to define what programs will run when you enter a certain run level. The syntax or format for init tab entries is identifier, run level, action, process. ID or identifier is a sequence of 1 to 4 characters that identifies the function. Run level is the list of run levels for which this entry applies. Action, of course, is the action to be taken, which tells init how to treat the process. And finally, the process field tells Linux which process to run for this entry. Now it should be noted that some distributions are abandoning use of the etc init tab file in favor of etc event.d. You'll have to look at your individual distribution to see which configuration file is used, but for the purposes of the certification exam, etc init-tab is the one you should focus on. System V or sysv startup scripts run all scripts that are associated with the current run level. These run level scripts are stored in etc/r.d/rc?d or one of the other locations that you see here on the screen, and the question mark indicates the run level. You only need to search for the directories or check your documentation to see which one you have. The sysv directories are actually links to main scripts, which are usually stored in either etc.rc.d or one of the other two locations that you see here. And you also have the option to start scripts manually using the start command. So for instance, to start sshd, you type in /etc/init.d/sshd space start. You can also use the stop, restart, or status commands with the script name. At this point, let's switch over to our terminal window and take a look at the contents again of the etc init-tab file. At the command prompt, let's type in cat, which again displays the contents of a file, followed by a space, /etc/init-tab. Let's hit enter. The pound signs that you see here in the output constitute comments. These are informational lines that are ignored by the program. If we scroll up, we'll see that the first comment line indicates that init-tab is only used to set the default run level, which you see on the last line of the output here. For my distribution, Fedora 13, if you look at the comments, you'll see that system initialization is started by etc init rcs.conf, and individual run levels are started by etc init rc.conf. Let's check out run level scripts, which run again depending on the run level indicated. Now they can be stored in etc under subdirectories that begin with either rd or rc. Fedora uses the naming convention rc plus the run level number. Let's take a look at the contents of that directory. So let's type in ls, which will list the contents of the directory, followed by etc/etc/ let's start with rc0.d and hit enter. Again, this will show all of the startup scripts that should be run if the run level is at 0, which is the transitional run level again, which shuts down the system. Now let's check out the next one. We'll type in ls again, /etc/rc1.d and hit enter. And again, this will display all of the startup scripts that should be run if the run level is set to 1. And 1 again is single user mode, and that's used primarily for maintenance. Let's try another couple. Type in ls again, /etc/, let's skip ahead a few. We'll try rc5.d. And again, rc5 is multi-user mode with the graphical interface, which is, of course, our default as well. And let's hit enter. And again, these are the scripts that should run whenever we are set to run level 5. So you probably are getting the picture. Depending on the run level, numbers 0 through 5, each of these directories will contain the scripts that should be run when the system boots up. If we take a step back, based on what we've covered so far, you should have a fairly good understanding of what a run level is, the standard 7 Linux run levels, and their uses. Armed with this information, it's time to get into how to manage them. You may need to change the default run level for yourself or in a networked environment for your users. In addition, there may be processes that you'd like to start automatically. If you're testing or troubleshooting, you'll have to change the run level at the command prompt. And there are a few utilities that will help manage the symbolic links to your sysv startup scripts we talked about on the previous slide. Let's examine each of these in more detail. Run levels is a concept best understood through practice. Let's go back to our terminal window and type in the command run level. First, of course, let's clear the screen with the clear command. Now if we type in run level and hit enter, you can see that right now my current run level is 5, which from our chart means that I'm running in multi-user mode with the graphical interface. The S in front of that means that previously I had been running a single user mode. Now before, we reviewed the contents of the etc init tab file, and we saw that the default run level was at the bottom of that file. And if you want to change it, you just need to modify the option there. Again, keep in mind that some distributions aren't using that file and are instead going towards etc event.d. Your process declarations may be stored in another file, so you'll have to consult your documentation to find out where. As an administrator, there are times where you will need to change the run level from the command prompt, most likely for testing or troubleshooting purposes. Both the init and telnet programs allow you to make this type of change. Let's try changing run levels. You may have to reboot your computer, so it's best to do this, as with all the exercises, on a test system without any other users connected. Init, if you recall, is the first program the kernel runs, but it has another function. Say you've modified your etc init tab file, and you'd like to have your system reread that file and implement the change, or simply to switch to another run level. Say we wanted to switch to a single user mode to do some maintenance. Actually, before we do that, this command requires root privileges, so we're going to have to obtain root. Again, on Fedora, you do that by typing SU for superuser and then entering your password. And of course, I didn't type in the password correctly, so let's try that again. Okay, from here, let's try typing in init space 1. You're going to see the system restart. And we're in single user mode as indicated on the screen. So if we type in run level from here, we should see run level 1. So now to go back where we were before, I'm going to type in tel init space 5. From here, the system should reboot, which will take just a moment. Need to enter your user password. And once your system reboots, let's open a terminal window again. And let's type in run level. And as you'll see, we're back at run level 5. And again, the S indicates that previously we had been in single user mode, or 1. The next command is shutdown. And it does exactly what it says, but first it sends a message to all logged in users, and it keeps others from logging in while the run level is changing. Options for this command are now, -R for reboot, -H for halt, but not power off the system, -P to power off, and -H to halt or power off, though that's usually a power off depending on your system. Administrators will favor the -H option as it gives users a heads up before rebooting. Syntax for such a command could be shutdown space -H +5 for the number of minutes you're going to give for users to log out, and then in quotes you're going to have the message. And finally, Run levels can be changed with either the halt, reboot, or power off commands. Let's move on and take a look at some utilities that can also help with managing run levels. Okay, so we know how to change run levels, but say you just wanted to change a run level service. How could you quickly check the services and their current run levels? Why, with the check config command, along with the -- list option. So the command would be check config space -- list. Let's give that a try. Let's clear our terminal window again with clear, and let's type in chkconfig space -- list. You'll see the list of services in the first column. Let's scroll back up so we can look at the top. Again, we have the services here in the first column, followed by one column for all 7 run levels. The off and on indicates whether or not the service is active for a particular run level. For instance, the Bluetooth service is only active, as you can see, for run levels 3, 4, and 5. 0, 1, and 6 are in the off position. Next, let's go back to our slides and review another utility. The next command is ntsysv, which is used on Red Hat and its derivative distributions like Fedora and Mandriva. You simply type in the command without options to configure your current run level. Now this is a text mode program, so you use your arrow keys to move up and down and the space bar to toggle on and off. You can also use the -- level option to specify alternate run levels to configure. Let's take a quick look at that. First, let's clear our terminal window with the clear command. Then we'll have to obtain root privileges, again with the su command. And then we'll need to type in ntsysv. And what you see here on the screen is the program. Again, you can use your arrow keys to move up and down, and your space bar to toggle on and off. I'm just going to cancel out of here and not make any changes. And let's go back to our slides. That concludes our lesson on run levels and system shutdown and reboot. Let's review what we've covered. Run levels was a confusing concept for me at first. Lots of commands, lots of options, and initially no idea when I'd really use any of this. But administrators will find that they rely on run levels quite a bit. Usually any system administration duties you need to perform will need to be done in a mode where minimal resources are loaded and users aren't connected to the network, or as we learned, run level 1. In this lesson, we learned that run levels were a mode of operation, similar to Windows Safe Mode. We talked about Linux's default run levels and services, and how to manage them both from the command line and with other utilities. Certification candidates should ensure that they've memorized the 7 run levels and their purpose, how to change and set the default, and otherwise manage run levels and their contents and locations of a init tab in the sysv startup scripts. Thank you for watching, and I'll see you in the next lesson.